Good afternoon. Okay. Okay. Good afternoon. My name is Muhammad Arif Makir Wibslan from the Md Yusri, and my registration number is 09DMB20F1016. And I want and this is my friend. Please introduce yourself.
Hello, my name is Muhammad Aizat bin Muhammad Kausalan and my matrix number is 09DMB20F1022.
Hello, Assalamualaikum, everyone. My name is Nick Muhammad Afid from Bizgifli, and my matrix number is 09 DMB20F1018.
Assalamualaikum. My name Muhammad Nasrul bin Azami. Matric number 09DMB20F1020.
Okay, and we shall start our presentation now. This is our presentation of application of integration in architecture. This is our front page, and I'll just start with the introduction. What to know about integration? Just sorry for a bit, zooming in. In definition, integration is a technique of finding a function and derivative of which is equal to given for another function. This is indicated by integral of the usual sign of slightly f, which means this is integral symbol of f, where f, for example, usually called indefinite integral to the function. The symbol of the x represented the infinitesimal displacement along the x. Thus, fx is the summation of product of fx and the x. The application of integration in architecture is used to gain the area below the curved shape of the building. Usually, integration is used during the blueprint processing step, like a planning process, or before usually bidding given to the contractor to start building the building. For example of this is Burj Al Arab in UAE, which is this picture here on the right side, and Al-Dawr HQ building in Abu Dhabi, UAE at the left side here, as you can see. Alright. Now let's start with question number 2. And question number 1. Alright. Can you guys start now?
Yes. Okay. Firstly, all. The question is determine the area of below and above the axis. Okay, let's start off with getting a sketch of the region we want to find the area of. So we are assume that at this point you are capable of graphing most of the basic function that we are dealing with in this problem. And so we won't be showing any of the graphing work here. Here is a sketch of the bounded region we want to find the area of. Height step 2. Nasrul.
For step 2, it was to be clean from the graph, and the upper function is the parabola is y minus equal to 3 plus 2x minus x squared, and a lower function is z y equal to 0. Since we give a limit on the x, the problem statement we need to get to from the graph, it looks like the limit probably. However, we should never just assume the graph it includes that we able to read truly. For all we know, the limit close to we guess from the graph, but is they're different.
So let's slate?
No.
Okay.
So to determine if we guess the limits correctly from the graph, let's find them directly. The limits are where the parabola cross the axis, and so all we need to do is set the parabola equal to 0, where it cross the line y equals 0, and solve doing this case. So x plus 2x minus x equals 0. So we did guess correctly, but it never hurts to be sure. That is especially true here, where finding them directly take almost no time. Step 3, Nasrul.
For step 3, at the point there are much to do other than step up integral and absolute it. We assume that you come comfortable with the basic integral technique, so we need to be include any discussion for a actual integral process here, and we will be skipping some the intermediate step. This area minus 1.
Okay.
Next slide.
Okay.
Arif.
Next slide. Alright.
This is the to find the area and the curve fx. Just that from for question 1.
Alright. So now we got the answer of the area below the parabol is 32 per 3 unit square. Alright. In question 2, find the area bounded by the following curve, which is y equals to x powered by 2 negative 4 and also y equals to 0 and x equal to 4. So in this case, the question have included the graph here and a set of the boundaries. So we will find the area that is bounded by the boundaries here. So that as you can, so for first step, we're gonna find a boundary A first. So on the question here, we selected for the function here, we set y equal to 0, and so the function will be 0 equals to x powered by 2 negative 4. So we turn that into x powered by 2 equals to positive 4. We can put it to the right of punca kuasa 4. What's it? Sorry. What's the equation here though? Of radical here. Square root 4. I apologize. So that equals, so we can get x equal to 2. Now that's how we got boundaries A equal to 2. Now for boundaries B, we have seen that x equal to 4 and A is 2. So we can directly took that B equal to x equal to 4. So boundaries B equals to 4. Alright. On the next step, Afif.
So this question is find the area bounded the following the curve is y equal to x square minus 4, y equal 0, x equal 4, and following the graph is this. So find the area bounded by the curve is integral of x square minus 4 dx equal
This is integral.
the integral is x
Square root.
power 3 x square root per 3 minus 4x. So the integral of which 4
Cube root.
4 cube
4 powered by 3.
4 power 3 per 3 minus 4 multiply 4, and the minus also is 2 power 3 per 3 minus 4 per multiply 2. And the answer is we got 16 per 3 minus negative 16 per 3. So the answer is 32 per 3 unit square.
Alright, thank you. So that's conclude for the example of question of integration here. To include to conclude our presentation here, integration has made a vital part in designing a building that is sturdy and beautiful in its structure. As we can see from here that over time, mankind designed challenging the nature itself by building a higher and even a higher building and make it even more complex than their predecessor from the years before. The discovery of integration has also boosting our knowledge in designing more complex structure over time that is also sturdy in its own beauty. So for the to end this inter, to end this presentation, integration has made mankind jump into a realm where the impossible has become possible, where the sky is now not a limit anymore. So thank you. So thank you for watching our presentation here. Have a good time. Thank you. Assalamualaikum.
Assalamualaikum.
Uh, now